see the ultrasonic welding. You can see the ultrasonic welding process where you can see observe a vibrating device which is moving in the downwards direction, and it is vibrating, and because of the vibration there is some kind of frictional heating going on, and because of this thermal energy generation the materials, the workpiece are held together or they are joined by this welding process. So if you see or observe the definition, you can see that ultrasonic plastic welding, generally it is used for plastics, but in some cases metals can also be welded through the ultrasonic welding, but obviously uh, it should be a low melting point material. Okay, so ultrasonic welding is
স্যার সব্য জিজ্ঞেস করছি এটা কি স্পট ওয়েল্ডিং এর মতন?
can you please repeat once?
এটা কি স্পট ওয়েল্ডিং এর মতন?
Somehow like spot, but in case of spot you will find two electrodes, but actually the mechanism of heat generation, or thermal energy generation is different from spot welding, but you can find similarities from spot welding. Okay,
Okay, sir.
in case of spot welding, what happens? There is fusion. Okay, the material is melted, but in case of ultrasonic welding, there is no melting of the material. It is entirely because of the pressure which is being applied and because of the acoustic vibration. Okay, these vibrations obviously has a certain frequency which ranges between 20 kilohertz to 75 kilohertz depending on the workpiece which is to be joined. Okay, so the energy which is being supplied during this welding process, that is different from spot welding. Okay, now here you can see, so high frequency electrical energy into high frequency mechanical motion. Okay, that means you will I will show you the parts how this conversion is going on from this electrical energy to mechanical motion. That means how we are obtaining this vibration. Okay, that is a separate part to discuss. We will discuss later on. But first of all, there is electrical energy which is getting into mechanical energy. This mechanical energy is creating the vibrations, and this mechanical motion along with the applied force, it creates the frictional heat at the plastic components or the mating surface of the plastic components. Okay, so that plastic material melts. Generally this melt word is not correct, because melting is not done in case of ultrasonic welding. Okay, so I would like to mention the history of ultrasonic welding. Okay, ultrasonic welding was invented in the year of 1965. Okay, so what happened? This was invented by an accident actually. What happened actually? Uh, there was two persons who were working in a company called Sonics and Materials Inc. Okay, so the name of the two persons were Robert Soloff and Seymour Linsley. So what happened? They were doing the welding of hard plastics. Okay, they are welding of hard plastics, and by accident, what happened? This man Robert Soloff unintentionally moved this probe which you can see that it is moving in the downward direction. Okay, so what he did, he unintentionally did. Okay, he moved the probe close to a plastic tape dispenser. Okay, he moved this probe closer to a plastic tape dispenser, and he saw that the halves of the plastic tape dispenser were welded. Okay, so then he understood that there is no requirement of moving this probe by manual force. So he understood that if we apply some kind of ultrasonic energy so that these vibrations can be created, then the parts can be welded. Okay, and he also understood that this ultrasonic energy could travel through the rigid plastics and create this weld, and it can create an entire joint. Okay, so this was invented by accident. Now what happened in 1969? In 1969, so after the invention of this ultrasonic welding, and an entire car made of plastic was brought into the market. So the car, every part of the car was made by ultrasonic welding. But the car didn't run well. But what actually ran was the process of ultrasonic welding. So the process of ultrasonic welding became a masterpiece. But the plastic car didn't run in the market. Okay. Now we will move on to the mechanism of ultrasonic welding. So here again you can see an animation, and you can see that there are some written information over there. Now what do we mean by horn? This the In this figure you can see that the blue part, okay, that is the horn for you. The downwards part, this is the main vibrating object. Okay, the energy transfer is done in this case. So what is the mechanism? The mechanism is that the parts which are to be joined, they are held together. Okay, the parts which are to be joined, they are held together. They are held together, and you can see that these two materials are held together closely, and this is your horn, and this horn is made to vibrate in made to create ultrasonic vibrations, and the frequency range is between 20 to 40 kilohertz. Okay, and you can also understand this is somehow our normal hearing range. Okay, so now when these ultrasonic vibrations are switched off, suppose after some time we switch off the ultrasonic vibrations, what will happen? The welding pressure would be maintained. That means this horn and these surfaces, the workpiece surfaces, they are in contact. Okay, and there is some amount of pressure applied to the surfaces. Okay, so what happens when these ultrasonic vibrations are switched off? The welding pressure is maintained therefore, and they create these thermoplastics to create they create this pressure, and this helps these thermoplastics to create the weld joint. Okay, now the time required to create one single weld is very small, very less. It is less than 1 second. We can create a joint within 1 second. So here you can see the horn applies pressure to the plastic materials. Okay, the horn vibrates vertically at 20,000 to 40,000 times per second. That is the frequency for you. 20 kilohertz to 40 kilohertz. The vibrations create frictional heat that causes the materials to melt and flow together. Okay. So these the ultrasonic waves which are being created by this horn, they create a dynamic shear stress. Okay, at the interface of the workpiece, this horn creates a dynamic shear stress, and because of this dynamic shear stress, what happens? Local plastic deformation happens. Now you know what is plastic deformation. If you apply stress, then there will be corresponding strain. Okay, up to a certain limit, which we call as the elastic limit. If you remove this stress, or if you remove this force, then the material can go back to its initial condition. Now what happens above this elastic limit? If you go on applying this force, creating this stress, then there will be permanent deformation. So this permanent deformation range is called as the plastic deformation. So plastic deformation means the material is going closer to break down. Okay, so these ultrasonic waves, they are creating this dynamic shear stress, this dynamic shear stress. What is happening because of this dynamic shear stress? They are creating local plastic deformation, and because of this plastic deformation, there is a generation of thermal energy. Okay, so this is entirely because of the friction. This is entirely because of the friction between the horn and the two plastic materials which are to be welded together. Okay, is that clear?
Yes, sir.
Do you have
Yes,
any
sir.
questions?
No, sir.
Okay, so this is the welding process for plastics. And when we do the ultrasonic welding for metals, what do we do? We know that the greatest hurdle to do any welding is its oxide layers. The oxide layers which are deposited on the surfaces. Okay, so any ultrasonic
স্যার
welding, yes,
স্যার বিশ্বরূপ বলছি। স্যার
হ্যাঁ,
সব্যসাচীর একটা কোশ্চেন ছিল, সেটা হচ্ছে বুস্টারের কাজ কি?
okay, we will discuss this. Okay, we will discuss
ওকে
this. We will discuss every part. Okay, the details of every part. What is the okay?
ওকে
What
স্যার,
is
ওকে
the
নো প্রবলেম।
construction of these parts and what are the applications and what purpose all these parts serve? We will discuss it. Okay. So
ওকে
now the
স্যার।
question what I was discussing was what happens when we do the ultrasonic welding for metals. Now, for metals, the greatest hurdle to do welding is its oxide layers, which are deposited on the surface. Now, ultrasonic welding is a very unique way, is a very unique process, goes through a very unique way to disperse these oxide layers. Okay, this is very unique and very effective. Okay, so because of this high pressure vibration, this oxide layers go on dispersing. Okay, and this and the local motion of these materials, and there is a local motion of the materials. Okay, so in case of metal, obviously there is heating, there is frictional heating, but still it is not enough to melt the materials. So it is obvious that this ultrasonic welding is a solid state welding process. And ultrasonic welding uses an unique way to disperse the oxide layers which are deposited on the surface. Okay, now we can see, now we can move on to the discussions of the equipment, the tools which are used in ultrasonic welding. So we'll start from the generator. Now generator, I was speaking about that earlier, that energy, the electrical energy is converted into mechanical motion. So obviously this electrical energy generation uh, is extremely necessary, and the conversion of electrical energy into mechanical energy should be understood well. Now what is generator? So there is a generator used in the ultrasonic welding. This generator converts the electrical power from the single phase mains to the correct frequency. So depending on the workpiece which is to be joined, the correct frequency is always selected. Okay, now the generator helps to convert this electrical power into the correct frequency and the voltage. Voltage for whom? For this transducer. Okay, so generator converts the electrical energy and converts the electrical energy in the correct frequency. So this correct frequency can range between 20 kilohertz to 75 kilohertz depending on the workpiece which is to be welded together. Generally, for plastics, it ranges between 20 to 40 kilohertz. So kilohertz means 20,000 vibrations in a single second. Okay, so you know frequency. So I am not going to discuss the concept of frequency. So this is the basic thing. Now, just a minute. Okay, now we can see the pneumatic piston, or which we call as the machine press. Okay, so this pneumatic piston helps the the motion, to create this motion. Okay, and this machine press has a pressure gauge and regulator, has a pressure gauge and a regulator for the adjustment of the welding force. Okay, to maintain the pressure, because I have already told you pressure and ultrasonic vibrations. These are the two main parameters of ultrasonic welding. So we are now discussing about the pressure which is to be maintained. So this machine has a pressure gauge and a regulator for adjusting the welding force which is to be required. Obviously, in case of plastics, the welding force which is required, it will be less. But when we are concerned with the metallic welding, welding of metals, then the welding force may be increased. That means high pressure can be required. Okay, so it should be mentioned, it should be noted that a particular gauge pressure set on one piece of ultrasonic welding equipment, okay, will not necessarily provide the same welding force. Okay, so if a particular gauge pressure is set on one piece of ultrasonic welding equipment, it will not indicate that it will be remaining same for another machine. Okay, so depending on the machine, the force requirement can vary. Okay, depending on the specifications of the machine, the welding force characteristics can vary. Okay, and now we can move on to the transducer part. Okay, so transducer is the most important thing. It is also called as the converter. Now, what does a transducer do? What does it convert? It converts the electrical energy from the generator. So transducer always receives the electrical energy from the generator at the specified frequency and the specified voltage, and then it converts this electrical energy to the mechanical vibrations which is required for welding process. Okay, now this transducer can consist of a number of piezoelectric devices which will be sandwiched between two metal blocks. Generally, this metal block is made of titanium. In some cases, you will find aluminium is also used. Okay. Now coming to the part booster, as Shobhosachi was asking. Yes, obviously, everything depends on the workpiece which is to be welded. Okay, everything depends on the materials which has to be welded by this ultrasonic welding. If it is metal, then obviously we will not use the same frequency, we will not use the same electricity. Okay, the voltage would be changed. So everything depends on the workpiece which is to be welded. This is true for any welding process. The process parameters will go on changing depending the requirement or depending on the cases which is to be welded. Okay, so this is a basic understanding. So nothing is permanent. No process is absolutely correct for welding. Okay, it varies depending on the workpieces. Now coming to the booster part. So this booster serves basically two purposes. There are two purposes of this booster. First of all, its basic purpose is to amplify the mechanical vibrations which are produced at the tip of the transducer. Okay, so this booster, so you can understand from the word booster, so you can say also it boosts the mechanical vibrations, or in other words, it amplifies the mechanical vibrations which are produced at the tip of the transducer. Okay, so this is the first part. Okay, now obviously this booster is well tuned depending on the requirements. Okay, so what happens? It resonates. Okay, this booster resonates at a specific frequency so that it can transfer the ultrasonic energy which it has received from the transducer. Okay, then so booster amplifies the ultrasonic energy which it has received from the transducer, and it transmits to the welding horn. Okay, you can see the welding horn over here. Okay, now coming to the welding horn. So the welding horn is the most important part as it supplies the energy to the component which is to be joined, which is to be welded. Okay, this design of this welding horn is very important, because depending on the design, the welding would change. Suppose I will show you a video of the plastic welding using the ultrasonic method. So you will see that the design of this horn may change according to the requirement. So in which shape you are trying to get your weld, what is your weld design, how you are going to achieve the joint, what is your shape, that these parameters are important to design this weld horn. Okay, so now the welding horn, uh, like the booster element, is also a tune device. Okay, so this tuning is very important. Okay, now this welding horn is generally produced of aluminium, titanium, or titanium. Okay, so aluminium welding horns are generally used for low volume applications. That means welding for plastics, you will see that aluminium welding horns are used. Okay, but when we are concerned with the welding of metals, we will generally use titanium for it. Okay, now the amplitude at as the amplitude in which the horn vibrates or is in between 30 to 120 micrometer. Okay, so these are the important parts of this welding horn, and the tip of the welding horn, delivers the ultrasonic energy to the component which is to be welded. The tip should be designed, as I was speaking, depending on our welding design, our weld joint design considerations. This specifically designed. Okay, so now let us show you. So I believe you have understood the the steadiness of this process, how much fast it is, and how the simplicity of the process also. I believe you have understood now. Okay, so these vibrations cannot be observed here because it is so much fast. But if you focus on this device, you will be able to observe the vibrations. And in that case, the materials which were to be joined, they were covered by this welding horn, so you weren't able to see the vibrations. But in the previous day, when I started with this session, I showed you this ultrasonic diagram. Okay, ultrasonic welding diagram. Okay. Now let us move on for the discussions of the ultrasonic welding parameters. Okay, so let us move on to the discussions of the ultrasonic welding parameters. So first of all, there are a number of
আর একটা প্রশ্ন করছে, ওখানে লিখছে কি কত মিলিমিটার মেটাল গজ অবধি এটা ওয়ার্কেবল আছে?
Okay, actually it is for plastics. Generally it is used for thin plastics. Generally I can say about in a range of 1 to 2 millimeter, because for thick materials this ultrasonic welding is not suitable. This is actually suitable for the very low thickness materials. Okay.
Okay, sir.
Okay. Now coming to the discussions on the welding parameters. Just a minute. So here you can see in this slide, you can see that I have shown you basically two parameters. So these are the two fundamental parameters which govern the quality of the weld joint. But except these two, you can see the down speed as an important parameter. There is a trigger pressure, which is very important also. The weld time, what is the time required for this welding, and for how much of time these vibrations may continue. There is another time which we call as hold time. Okay, so these are the also subsidiary parameters which are required. Now coming on to the basic parameters. Okay, so first of all, the most important parameter is the amplitude. So successful welding, any successful welding will depend on the proper amplitude of vibration. So the vibration which is occurring at the tip of the welding. The vibrations, the amplitude of the vibrations which are occurring at this tip of the horn. Okay, which are occurring at the tip of the horn, that is very much important. So basically, depending on the combination of this booster and horn, depending on the combination of this booster and this horn, these amplitudes can be changed. Okay. So suppose you want to weld a metal, then you must select a specific combination of a booster and a welding horn. Okay, you cannot go on changing, you cannot expect to change the amplitudes. You cannot expect to change the amplitudes if you have selected a specified booster and welding horn combination. That is always fixed. You have to change the booster and the horn combination entirely to obtain a different state of amplitude level. Okay. Now, in case of welding of the semi-crystalline materials, like ultrasonic welding is also used to weld electronic components, and they are called as the semi-crystalline materials. So in case of welding on the semi-crystalline materials, it would require much more energy. Okay, so obviously you need to select such combination which will satisfy that. That means the horn amplitude and the booster amplification, that should be selected in this way. So everything depends on the workpiece which is to be welded. Okay, this is a basic idea, and you should have this. Okay. Now, in modern machineries, you will see that these ultrasonic welding machines does allow the amplitude to be profiled. Okay. That means this higher amplitude can be used to initiate melting if melting is required at all. Okay, and then you can go on with a lower amplitude rate so that you can control the viscosity of the molten material. Now, let us move on to the discussions of welding mode. Now, how the welding is happening, that obviously characterizes the strength of the weld joint which is to be produced. Okay, so what do we mean by welding mode? How this welding is being created, how this welding is being done or performed. So this welding can be performed by three specific modes. The first one is welding by time, the second one is welding by energy, and the second one is welding by distance. So why are these three specific categories? Because in both the cases, in the three cases as it is mentioned here. In the first case, time is fixed. I will do the welding for a certain time. Then let us see what are the characteristics. In the second case, I will provide a certain amount of energy and I expect the welding to be performed within this range of energy which is being provided by me, by the operator obviously. And then the welding by distance. So these are arranged in the, if you arrange these parameters according to the quality of the weld joints which are being produced, you will find this welding by distance format. When we perform the ultrasonic welding by following this mode, welding by distance, it will always give you the maximum joint efficiency. Okay, now what is welding by time? Welding by time is is termed as an open loop process. Okay, now the components which are to be welded, they are assembled together in the tooling fixture before. So first of all, what happens? The components which are to be welded, they are assembled, and then the welding horn descends and makes contact. Okay, so this welding horn can move up down. So as I had shown you in the first case. So here you can see the welding horn is coming in the downwards direction and it is making contact. Okay, like this. So now, so when the welding horn descends and makes contact, then the ultrasonic vibrations are applied to the assembly for a fixed duration of time. Generally, the time range is 0.2 to 1 seconds. Okay, but the problem is that it doesn't give you a successful indication of a proper welding. It doesn't necessarily mean that if I give a certain time limit for 0.2 seconds to 1 second, it will give me the best weld joint. Okay, this is the basic problem. So this process, this mode works on this assumption that a fixed weld time will result in a fixed amount of energy transferred. Okay, that means if you provide the ultrasonic vibrations for a fixed amount of time, it will transfer the fixed amount of energy. And this fixed energy is enough to do the best joint. So it is an assumption. Okay, it is an assumption. It doesn't mean it doesn't necessarily mean that the material would be welded in the best quality. Okay, depending on the transfer of this amount of energy. Okay. Now coming on to the next process, welding by energy. So energy is a function of power and time. Okay. In the previous case, welding by time was an open loop process. Welding by energy is a closed loop process. Okay, and you can give feedback control. What do you mean by feedback control? Suppose you require a higher amount of power, or you require a certain amount of extra time so that the weld can be created at its peak. Okay, so this is an important addition to this welding process where you can give the feedback control. Okay, what will happen here? Suppose this ultrasonic welding software, it will measure the power which is being drawn. Okay, this power is being drawn from the electric generator. Okay, and this computer software, it will calculate, it will measure the power which is being drawn. And if sometime this power which is being drawn is going below the required amount, then the software can adjust itself and it can start drawing the requisite power which is required to necessitate the welding process. Okay, So this is the advantage of welding by energy mode above welding by time mode. Now, coming to the best part, the welding by distance. Okay, so welding by distance mode is the best thing. So welding by distance allows components to be joined by a specific weld depth. Okay, welding by distance always allows the components to be joined by a specific weld depth. Okay, now this mode works independently, independently of time, of energy, or power drawn. So there is no dependence on the time or energy or the power which is being drawn to which is required for this welding process. Okay, and welding by distance, this mode also compensates for the required tolerance level. Okay, now what do you mean by tolerance level? Suppose the weld the work pieces which has to be joined together, they are separated by a certain distance, or in case of lap joint there is some tolerance or some distance between the surfaces. Then in that case, this welding by distance mode, it will compensate for the tolerance required, and it will provide the amount of weld material which is required to provide an excellent joint. Okay, so these are the parameters, and now we can see the microstructures. Okay, so as here you can see, this is an experiment where it is basically a microstructure of a TIG welding, but TIG welding with 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 the applications of ultrasonic vibrations. This is not actually the microstructures which are being produced by ultrasonic welding. These are the microstructures which are being TIG welding, which are being created by TIG welding, but assisted by ultrasonic vibrations. And this you can see the ultrasonic vibration power is also mentioned as. Now for the starting one, for the figure A, you can see the grain size. So as we go on increasing the ultrasonic power, you can see the grain size goes on reducing. And I have told you so many times that if there is grain refinement happening, it means it will always give you a better quality of joint. That means it will give you higher strength and higher micro hardness. Okay, so here you can see the assistance of the ultrasonic power creating this grain refinement mechanism, so that you can find the joints of higher power and higher strength and higher micro hardness. Now you can see the applications of the ultrasonic welding. I'm not going to recite those. So do you have any questions regarding ultrasonic welding? Hello?
স্যার
Yes.
স্যার বলছি এখানে আপনি যে ফিডব্যাকটা বলে মানে ফিডব্যাক সিস্টেম যেটা বলেছেন, ওইটা কি সেম প্রসেসে যেটা আমাদের এই সিএনসি মেশিন ইউজ করে, মানে সিএনসির ফিডব্যাক যেরকম হয়, কি সেম ফিডব্যাক এতেই হয়?
And the mechanism is same, but there can be different components. Okay, the mechanism of closed loop feedback control is same for all devices. Okay, but the components which are giving you this closed loop feedback control, this can be changed.
আচ্ছা, ওকে স্যার, বুঝতে
Okay,
পেরেছি।
okay, okay. Any other questions or query? Obviously, it is of very high cost because it is a collaboration of electrical equipments, transducers. So these are of high cost. But the efficiency, the advantage of this is you can create mass production. Okay, mass production of a certain material can be done by this yeah, ultrasonic welding equipment. Okay, that would satisfy your needs. That would satisfy your costs. So basically, it is used in industrial purposes. So here this cost is quite a negligible factor because an industry can operate on a higher cost. It can afford afford this cost. Okay. Any other query?
Sir, I have a question.
Sure.
Sir, which type of industrial equipment can be made by this process?
Here we
Can
can
we
see
see?
basically plastic parts, microcircuit connections. These are the mostly used. The application of ultrasonic welding is mostly for plastic parts, welding plastic parts and assembling of electronic components such as diodes and semiconductors. These are the most. These are the
Okay,
areas of
okay, sir.
application.
Okay, sir. Thank you, sir.
Okay. What do you mean by hydraulic pressure? Pressure, the source of pressure can be anything. It can also operate on a hydraulic pressure also. But generally, it is a pneumatic system. It can also operate on hydraulic system. One can create a process where the pressure would be exerted by hydraulic means. So that depends on the design considerations. Okay, suppose anything when it is being designed, it is always designed on the base parameters. So when a designer have considered air as the source of pressure, then there are obviously some reasons that is why he has followed air, and he or she doesn't haven't used water or any other liquid to exert this force, exert this pressure. So pneumatic, I think probably pneumatic or air pressure is the best option. That is why they have taken this pneumatic pressure source. Okay. Any other query or questions? Okay.
Sir, can we get the link of your lectures?
Surely. I am continuously uploading in the YouTube. Actually, I haven't uploaded the lectures of the previous day. I
Yes,
will
sir.
give you in the WhatsApp group. Okay.
Thank you, sir.
Okay. Okay. So thank you. Goodbye, and we'll see you tomorrow. Okay. So tomorrow we will follow the same schedule. Okay.
Sir, tomorrow 11 a.m. will you take the class?
Sorry. Can you please repeat once again?
Tomorrow 11 a.m. will